In this video we have another trig integral to evaluate. So we have the integral of sine theta times sine of 3 theta. You can recognize this as a product, and we want to convert it to a sum just to make the integration a little bit easier. So we're going to use this formula right here. That's the thing with these types of problems. You have to utilize a lot of the identities involving trig functions, and this is one where we can convert the product of, in this case, two sine functions to a sum, or difference in this case, involving cosine. So there's the formula. So we'll go this route here then. This is going to equal to, so this will be the integral of 1/2, and then I'll have the cosine of the difference of these two, theta minus 3 theta. Theta minus 3 theta will be a negative 2 theta. But because the cosine function is even, I can drop the negative and leave it that way. And then it's minus the cosine of the sum of the two. Theta plus 3 theta is 4 theta. This will be d theta. And this is equal to, now we should take the integral. I'll leave the 1/2 out in front here. We'll integrate here. The integral of cosine is sine. So this will be sine of whatever the angle is. It's 2 theta. Now if it had that been just theta, then that would be it. But because it's 2 theta, incorporating the u substitution, you'd have to put a 1/2 out here. I won't go through that. I've done enough of those u substitutions, so I'll put the 1/2 right here. And I get minus the integral of cosine, again, is sine at whatever angle you're dealing with. In this case, 4 theta. And again, same thing here. Because it's 4 theta, if we let u equal to 4 theta, then this coefficient here would be 1/4. And we have the constant of integration. And we just simplify this. This is equal to multiply now by 1/2. This will be a 1/4 here. Sine of 2 theta minus, multiply by 1/2, it'll be a 1/8 here. Sine of 4 theta. And we have the constant of integration. And this is your final solution. Thanks for watching. We'll see you next time.